Hello everyone, this is Jay from BTYT Tech Library. Today we are going to learn the basic of routing, handling requests and parameters in Kotlin with Ktor by building a task manager application. Let's code along. First, let's create our project with Ktor project generator. Visit Ktor site's Create section, change the project artifact name and download it. Open and run it for check everything is okay. And now, let's display static HTML content. Open the routing.kt file within the source main Kotlin, our project plugins folder. Inside the application.configure routing function, we are going to implement a new route for the URL/tasks, which is displaying sample task list. To notify the client that we will be sending HTML, set the HTTP contents type header to text/HTML. After that, when we access localhost port 8080/tasks in our browser, we can see the to-do list displayed. Next, let's implement a task model. For to do that, first we need to create model types. Inside source main Kotlin com.btyt, create a new sub-package called model. Within the model directory, create a new task.kt file. Open the task.kt file and implement enum to represent priorities and a data class to represent task. Plus, let's implement some helper functions for smoother data representation on HTML. function task.tasks as row enables task object to be rendered as table rows, whilst tasks as table allows a list of tasks to be rendered as a table. Now our model is ready. So let's create a new task repository.kt file inside our model directory and make some seed data. Okay, we have our task model and sample data. Let's replace existing /tasks route from displaying static contents to providing a list of tasks. After we run the application and access to localhost port 8080/tasks in our browser, we can see an HTML table containing tasks. Before we go further, let's polish our mock task repository to more database interaction-ish looks like. Through this implementation, the added task will be preserved and duplicated tasks will be disallowed. Let's rerun the application and revisit the /tasks URL to see everything is alright. Okay, let's create the function to let user view tasks by priority. We are going to add a new route /tasks/by_priority/priority, where priority represents a query parameter that we will need to extract at runtime. If you are familiar with Spring Framework, this might remind you mapping request sections usage of @path variable. If the query parameter is absent, the server returns a 400 status code to the client. Otherwise, it extracts the value of the parameter and tries to convert it to a member of the enumeration. Should this fail, an exception will be thrown, which the server catches and returns a 400 status code. Assuming the conversion succeeds, the repository is used to find the matching tasks. If there are no tasks of the specified priority, the server returns a 404 status code, otherwise it sends the matches back in an HTML table. Okay, let's test our feature is working properly. Access to localhost port 8080/tasks/by_priority/medium in our browser to retrieve all the medium priority tasks. We can see our feature's normal case is working properly. How about error cases? To verify error cases, we need to use developer tools in our browser or third-party API client, application like Postman, Insomnia, etc. To verify for status code, let's send a GET request to localhost port 8080/tasks/by_priority/vital. We know there is no vital priority task in our data, So as expected, we will get response for not found. To verify 400, let's send a GET request with an invalid priority. Localhost 8080/tasks/by priority/important. And as expected, we can check the response is 400 bad request. So we have our seed data and new routes. Now it's time to write a unit test. Ktor provides its own test framework to support the automated validation of routes. Let's create a new directory within source called test and a subdirectory called Kotlin. Inside the directory, create a new application test.kt file. Normally, unit tests cover for normal cases, error cases, and edge cases. In here, we are going to implement tests for 200, 400, and 404 cases. So far, we implemented GET request for allowing user to fetch tasks with search criteria. This time, let's implement a route to create new tasks for users. In that case, the appropriate type of HTTP request is a POST. When you send data with a POST request, it includes the information from every form field. This info is specially formatted so that the computer can tell which details go together and ignore any characters that could cause problems. First, let's create the static contents for adding new task. Inside the source main resources folder, create a new directory called task-ui. And within the task-ui folder, create a new task-form.html file. As you can see here, after filling the form and click the submit button, it will send post request to /task URL. After that, let's make Ktor aware of our static contents. Navigate to routing.kt file within source main Kotlin, our project path under plugins. Add the following line into the application.configureRouting function. Restart the application and access localhost port 8080/task-ui/task-form.html in our browser. The HTML form should be displayed. Now let's add a handler for the form in routing.kt file. As you can see, the new route is mapped to post request. Ktor processes the body of the request via the call to receive parameters. This returns a collection of parameters that were present in the body of the request. In here, we are going to use Kotlin triple to check there are no blank inputs since we have 3 properties in task. If any of the values are empty, the server will return a response with a status code of 400. If everything is successful, we return 204 status code, no content. But we have possible exception scenarios to catch. One is illegal argument exception from enum handling, and the other is illegal status exception from adding task. Once we finish the implementation, we run the app and do manual test. Speaking of test, if there are new functionalities, new tests follow. The test involves sending two requests to the server. One POST request to create a new task, and another GET request to verify that it has been added. When making the initial request, the setBody method is employed to populate its body with content. The testing framework offers a FromURL encode extension method on collections, which simplifies the process of encoding data as the browser would. We are almost done, but before we close today's session, one more thing. Actually, we can refactor our routing. You may notice all of our routes begin with /tasks. So we can remove this duplication by placing them into their own subroute. How about that? If you feel like giving it a try, would you add a route for finding task by name? URL will be /tasks/by-name/task-name as variable. If request parameter doesn't exist, return bad request. And if there is no task with that name, return not found. You can pause the video and try if you like. Okay, let's see what it's like. Today, we implemented basic routing and request handling functionality along with validation, error handling, and unit testing in Ktor. In our next session, let's expand what we did together and create something widely used backend service, which is RESTful API.